All right, welcome back. So hopefully by now we're getting the hang of kinematics a little bit, and let's see if we can solve this problem. So we have a tennis player who is trying to serve this tennis ball and hit it across the net, right? So the goal is to hit the tennis ball, and it needs to cross this 0.9 meter high net, and it has to cross this 15-meter long horizontal distance, and the tennis player is about 2.5 meters tall. So when he or she hits the tennis ball, it's going to be at above the ground at 2.5 meters. And the tennis player is going to attempt to hit this ball horizontally, so completely horizontally when the tennis ball is served. So the question is asking, what is the minimum speed required so that this tennis ball can cross this 15-meter distance and this 0.9 meter high net? So hopefully by now we're comfortable with kinematics a little bit, so I'd encourage you to pause it and then check your answer after that. Alright, so I'm assuming you've hopefully paused and now unpaused and are willing to see how to do this. So, like I said, with any kinematics problem, always divide into your x and y. You always want to look at x and y separately. And they're always going to ask for 6 things: acceleration, v initial, v final, x initial, v final in the x, x initial, x final, and time. So let me just add my equal signs. Here we go. There we go. All right, and in the y direction, same thing. Acceleration in the y, v initial in the y, v final in the y, y initial, y final, equals, and time. All right, so even if you had no idea how to do this problem, always write out these 6 things for x and y, because you know that they're going to give you some of this information, and then whatever you don't get, you can put a question mark next to and use the kinematics formulas to solve those. So even if you have absolutely no idea, always start like this. So let's go one by one and see what we know. So what is the acceleration of this ball in the x direction? And again, unless there's some fuel coming out of this ball which is going to cause this ball to accelerate in the x direction, we pretty much can assume that it's 0 meters per second squared. On the other hand, gravity is this mysterious force in the universe that is always causing objects to accelerate downwards at a rate of 9.8 meters per second squared, and since it's down, it is negative. So gravity is acting on this ball, and that ball will therefore accelerate downwards at a rate of negative 9.8 meters per second squared. All right. Now, what is the initial velocity in the x direction? And that's what we're trying to figure out, right? The minimum speed required to cross this net. So this is asking, what is that minimum speed you have to give it initially? So we're trying to figure out that v initial. So we actually don't know this. That's our goal, to figure this out. So what about v initial in the y direction? And you might initially be tempted to think that we also don't know v initial in the y, but actually the problem tells you that we are hitting the ball horizontally, right? We're giving a complete horizontal initial velocity. So we're not trying to hit it as a 2D vector which would have an x and y component, or we're not trying to hit it completely up, completely horizontal. So therefore, the initial velocity in the y direction would actually be 0. So it's very important to read physics problems carefully, because every word actually kind of matters, right? If you kind of casually ignore this word horizontally, this could cause confusion and that would mess up the problem. So make sure you just read it carefully and look for these clue words, right? That we've shown in previous videos as well, and this is another one. So just look for these kind of cue words like this. All right, what is the v final in the x direction? So we don't know what it is necessarily, but we know that since there's 0 acceleration and we are starting at some velocity which is unknown, we know that the final velocity in the x is still going to be the same initial velocity in the x direction, right? So for those of you who haven't seen the previous videos, I'll just quickly recap that if you're starting off at some initial velocity and you have zero change, right? Because acceleration is just a change in velocity. So if you're starting off with something and you don't change it at all, you end up with that exact same thing. So even though we don't know what we started off with, we know that we're going to end up with that initial velocity in the x. So that's kind of neat. On the y side, we just don't know what that final velocity is in the y direction because we're starting off at 0. We are changing negative 9.8 meters per second every second. So therefore, we have no idea what it is when it reaches that point. All right, the x initial is 0, the x final is 15, and the time is unknown. The y initial is 2.5 because we're starting 2.5 meters above the ground, and we end 0.9 meters above the ground. So that's what we're looking at, and what is the time, again, is unknown. Great. So our goal is really to figure out not just v initial, but really v initial comma x, because there is no v initial comma y. It's 0. So generally speaking, thus far, whenever we've needed a variable like v initial comma x, we typically go directly to the x side, right? Because if you need v initial and x, I've pretty much stressed, always stick to x or y separately. Don't mix them together. So that's the natural instinct. So let's see if we can do that. So we need v initial in the x direction. So what kinematics equation can we use to get v initial in the x? And the problem is that we don't really have a lot of information on this x side, right? So let's see. Can we use v final? Oh, whoops. Let's see. Let me draw it here. So can we use v final x equals v initial x plus a x t? Can we do that? We can't, right? Because we don't really know what v final in the x direction is. We know it's the same as v initial in the x, but then that'll just kind of cancel everything out, and then you'll have 0 equals 0. So that doesn't work. Can we use our next kinematics equation, which is delta x equals vixt plus 1/2, oh, that's getting messy, vixt plus 1/2 axt squared. And the problem with this one is that we don't know time, right? So we're kind of stuck with this as well. So that doesn't work. And our last option is v final in the x direction squared minus v initial comma x squared equals 2a delta x. And again, we can't do this because we really don't know. Well, we know v final in the x is the same as v initial in the x. So if we plug that in, we're just going to get 0 equals 0. So again, all three of these do not work. So this is why I wanted to do this problem, to highlight one more way they can kind of trick you on exams and stuff, is they can give you a problem like this where you need something, let's say in the x direction, and nothing works out. So a lot of people get puzzled at this point and kind of give up. But you have all this information on the y side, right? But I just said you can never mix the two, which is true. So you could never say, when I say don't mix them, I mean you can't say v final x equals v initial x plus a yt. You can never mix x and y in the same equation. That's a big no-no. But what you can do is you can actually use the y side to figure out time, and then once you get time, you can plug that in here, and once you have time, you can now go back to your x side. So time is one of those unique variables that kind of serves as a common link between both sides. It's really not an x variable or a y variable. It's both, and that's why we kind of just put it on both sides. So whenever you're kind of stuck like this, see if you can solve for time on the y side and then plug it into the x side, or vice versa, right? Depending on your situation. So let's see, can we do that? Can we solve for time on the y side? And we can. So what should we use? We can use delta y is equal to VIY, let me write this more neatly, VIYT plus 1/2 AYT squared. Okay, and let's see, delta y is final minus initial, so this is 2.5, so 0.9 minus 2.5, which would get you negative 1.6 equals 0 plus 1/2 times negative 9.8 times t squared. And if we solve for time, we will get 0.57 seconds. So we got time. Now we can say this is no longer question mark. Now we know this is 0.57 and this is 0.57 here. Now can we use one of these three equations and get our end goal of v initial in the x? And we can, right? So we still can't use this top one, but I think we can use this second one. So let's try that. We can say delta x is equal to vi x t plus 1/2 a x t squared. So delta x is 15. You're going from 15 minus 0, so that's 15. V initial in the x, we don't know. That's what we need. The time is, whoops, this is VIX. The time is 0.57 plus, and then this, all of this is 0 because the acceleration in the x direction is 0. So that's just 0. So let me write that properly. 0. Okay. So if we just plug that into our calculator, we'll get v initial in the x direction is 26.3 meters per second. And there you go. That is the minimum speed required, 26.3 meters per second. So what's the big picture from this problem? What's the theme? So let's write this is another theme, another way they can trick you. And it's a good one. So the theme is sometimes, although you keep x and y completely separate, sometimes you have to use information from the x side to solve whatever variable you want in the y side, or vice versa. Actually, this is what we did in this problem. We used information from the y side to get information on the x side. And what is that common variable that kind of links these two together? That's usually 99% of the time, that's going to be your time, because once you figure out time on one side, you can use it on the other side.